All right, so a uniform solid disc, mass 2 kilograms, radius 0.2 meters, rotates about a fixed axis, which is perpendicular to its face, and it's rotating at an angular velocity of 6 radians per second. Imagine the disc is resting on a frictionless surface, or it's sitting on a frictionless surface. What's the angular momentum of this disc if the axis of rotation passes through its center, so directly down the middle? And second, when the disc was at rest, in order to get it rotating, a force was applied perpendicular to the edge. If that force was 1.1 second, what was its magnitude? All right, so two parts of this problem. So let's kind of look at what we have going on here. So we have a disc, and I'm going to look at a top-down view. And you can imagine that the axis is running perpendicular to its face and right through the center, as I've indicated. So this disc has a mass of 2 kilograms, and it has a radius of 0.2 meters, so we're given that. It is a uniform solid disc, so if we look up the moment of inertia for a uniform solid disc with the axis of rotation perpendicular and directly through its center, we find that the moment of inertia relationship is 1/2 the mass times the radius squared for that disc. So the first question is, what is the angular momentum? We know that angular momentum, so this is part A, is equal to the moment of inertia times the rotation. And so we want to know the angular momentum when the object is rotating at 6 radians per second. So that was part 1. So relatively straightforward part A. So its moment of inertia is 1/2 the mass, 2, times the radius, 0.2 squared, times its angular speed. All right, so when we do that relationship, we find that the rotational momentum is 0.36 kilograms times meter squared per second. Pretty straightforward. All right. Part B says, in order to get this object to that momentum, required a force, right? So in order to change an object's momentum, impulse, it requires a force. If that force acted perpendicular to the edge of the disc, so like this, and the time of that force was 0.1 second, what is the magnitude of that force? So we need to not only appreciate that an object's rotational momentum is a state that we can calculate, we also know that to change the object's rotational momentum, we have a torque times the time that that torque is applied. All right? So if the object started at rest, the change in momentum is what it got to, 0.36 minus the rest, 0, times the torque, times the time of 0.1. So what is that torque? Well, it's applied by the force, and we know that a torque is equal to the force times the radius times the sine of the angle, right? To get an object to rotate, we care not only how large of a force we have, but where it's acting and at what angle it's acting. We said the angle is acting perpendicular to the edge of that disc, so the sine of 90 degrees becomes 1. And we find that the force times the radius of 0.2 is equal to my torque. So we're going to put that back in here. And we have 0.36 equals the force times 0.2 times 0.1. And if I solve for the force, I find that the force is equal to 18 newtons. All right, so recognizing that we have a rotating system, in order to get that object to rotate, to have an angular momentum, we have to apply impulse force. That impulse is related to the torque, the force, to get it to rotate, which we call that torque, times the time. And that torque then, remember, is the actual force, where it's acting and what angle it's acting. All right, good job.